Okay. Title of my talk is, this one is Global Warming, Where's the Alarm? It's going to be a different sort of talk than you normally hear about on global warming. And I know your time is valuable, so I'm going to ask you to fasten your seatbelts, and we're going to go through this quite a bit. And I'll probably skip some slides here just to keep us a little bit more on time. I like what John Tierney of the New York Times said. He said, I always wanted to be a scientist, but went into journalism because the peer review process was a great deal easier to sneak through. I think that's very clear on journalism in terms of climate change, because so much of the media has been hard over on trying to alarm you about something, whatever it is. And so it's really gone overboard, I think, on this particular issue. There's been a lot of articles recently and scrutiny about climate work because of some released emails from East Anglia University in England. But the quote, not from the email, but about the email thing, which indicates, scientists can be devious and they can act pretty much like anybody, like people. But the quote I liked the most was, when we don't know what you're doing, we don't know what you're doing wrong. And that's very important, that when you are dealing with an issue that has billions of dollars, trillions of dollars of impacts on society, raising your taxes, for example, don't you want to know exactly how people are coming to the conclusions they come to? Well, that's what science is supposed to be, open, transparent, and so on. And we've seen that that hasn't really been the case in some of the cases here recently. Okay, Michael Crichton said several years ago a very accurate statement that consensus is not science. You hear the consensus of scientists says this. Well, that's a political notion, and I've been on many of these panels, and I assure you, that is a political notion. It's who can be the biggest bully in the room, basically, and get across a particular point of view. And then, as time has gone on, especially with these consensus reports, just you weed out the people that you don't want to help contribute to them, and so it becomes a consensus of those who agree with the consensus. But fortunately, Lord Kelvin did tell us what science is, and he says all science is numbers. So if you want to say something scientific, you really have to put it into a metric. You have to say it in terms of a number. Just a couple of basics. Carbon dioxide is essential for all of life. You hear it sort of demonized a lot, but plant food is the best definition of carbon dioxide. In fact, 16% of the worldwide food production is due simply to the extra CO2 we put back into the atmosphere. Fantastic, wonderful, tremendous benefit that this world has received because of that extra CO2. And climate is always changing. The global temperature is either rising or falling. It's never going to be static. Sea level is rising or falling. Same thing. Glaciers are retreating or advancing. So what we do in climate science, and the type of part I'm in it, is we'd like to test hypotheses, assertions people make about the global climate and about global warming. And we in Huntsville actually are one of the few places in the world that builds lots of data sets from scratch. I mean, we start with the digital counts and satellites. We start with the original balloon releases or with dusty records from an English library or so on. And we build the data sets from those things to test these assertions. And what we found is that the popular surface data sets that you saw a number of them here before overstate what warming is occurring. For example, this is the one that shows the temperature for the last 160 years, and we're pretty much told that the first part of those variations are basically due to Mother Nature, but that last rise at the end is due to human effects. And there's no doubt that carbon dioxide has gone up. I mean, that's for sure. And carbon dioxide is a thermal gas, so it will cause warming to some extent. Okay, so that's pretty much a no. That's one of which there really is a consensus about most people. Okay, but let's look at that surface temperature data set. That's what we do, is we build these things from scratch. This is California, actually where I grew up. Well, you all know that's the Central Valley of California in the center of the picture, and it's green. But this is July, and that's a desert. I know it's a desert because I was born and raised there. I used to chase tumbleweeds down the streets on windy afternoons. But because of irrigated agriculture, this is now a green, moist, vegetated plain. That changes the climate. It's got to have changed the climate somehow. Now, right adjacent to that, you see the light tan, the foothills of California that are really very dry. Well, I was able to put together information from the Green Valley, as it's now become, and the foothills that are basically unaffected of development through time. And so what we found, if we look at the upper left graph, here are the temperature records of the last 100 years of the valley nighttime temperatures. And you see that in the valley, on the orange one, the temperatures are shooting up, whereas in the adjacent area of the Sierra Nevada, they're not going anywhere at all. If you look at that upper right-hand corner, that kind of explains it. What it says is just this. Whenever you have human development of the surface, you're going to create the situation where the things that make it cool at night don't make it cool at night. And I see Justin Walters in the back there. He was actually an author, a lead author of a paper that helped us look at this very carefully. The things that make the air cool at night are disturbed whenever you have buildings, you have irrigated agriculture where there had been a desert, where you have aerosols in the atmosphere. All those things foul up that process. Now, if you go to the daytime temperatures, in both the valley and the Sierra next door, you see there's no change at all. And this is an indication that what is happening in terms of warming is not due to something like large scale, like greenhouse gas increases or so on. In fact, the fact there's no temperature change at all is a real surprise for Californians to understand, at least in the daytime. But certainly at nighttime, which has a big impact, you see the temperatures are rising dramatically there. Another problem with that surface data set that was shown is that a lot of the stations are just fairly poor. This happens to be East Africa, the red there, that is from one of the popular surface data sets that's been shown here. And it's basically, it's in the same area where Kilimanjaro is and so on. This is basically just one station, Nairobi, Jomo Kenyatta Airport. Now, I lived in Africa. I lived right here in this area, and I knew about lots of stations from tea plantations of the past. The Brits were great record keepers, by the way. And railway stations and all kinds of places like that. I ended up with 46 stations. I had to enter them by hand from paper records, but was able to do that, recreate the data set with real solid information, and this is what's happened in East Africa over the last 100 years. Virtually nothing, absolutely nothing significant at all. And so we find here that, the problems in that kind of data set are fairly remarkable, I think, and unable to tell you a lot. In other words, it's a poor proxy for telling you what's happening with the greenhouse effect. That type of surface data set is a poor proxy for that. Now, another thing we do is we test hypotheses about global warming by testing assertions based on climate models. And what we found is climate models overstate the warming. Now, Gavin showed you a number of comparisons there, and I could see through quite a few of those. I didn't agree with the way they were presented to you. But one of the things you've got to remember is that models match the temperature over the last 100 years. This is why that's not an experiment in science. Every modeler knew the answer ahead of time. Every single modeler knew the answer ahead of time. So it should not surprise you at all that a model is able to reproduce what has happened in the past. But we've checked out a little different way. This is similar to what Gavin showed. This is the 1988 predictions by Jim Hansen, where he showed what temperature should do for the planet, and that yellow line there is if there was a drastic reduction in the CO2 emissions. And so, well, that's a hypothesis, that's an assertion. So now we can compare that with real data, the kind that we build up here. So that yellow one means you pretty much cut off CO2 increases around 2000 or so. Here's what really happened in the world. And you see that even the actual temperatures fell far below even the scenario that did not happen. Now, I've added in here 1 month of January 2010 that I just ran the satellite data for last week to show you that for 1 month we have a pretty hot month, and it's because of the El Nino out there, and it's just getting up to this scenario that did not happen, but certainly not up to what is going on here. And then you might see a picture like this that says, okay, here's this cloud of model results, and the average is this black line. And look how well the temperatures sort of match the black line. Well, there's some funny business going on there. First of all, most of that record, the modeler saw the answer ahead of time. Always be suspicious when the modeler knows what he's supposed to shoot for. But let's look at each model, not just the cloud. Let's look at each of the models, and here's what all the models look like. Now let's test each of their trends over time. Not the cloud, but let's look at each trend over time. And what we see here is the following. Now, this looks pretty messy, I know. But each of these is a trend that ends in 2008, that starts in this period, 30 years ago, 25 years ago, 20 years ago, roughly, and 15 and 10. What you see here is here's the average of those models, way up here. Here's the spread of the models. They're all over the place. Here are the 3 observational networks we have, showing that, no, those models do not agree with what has happened in the real world. They do not agree if you just look at the evidence here. About twice the warming. Here is a better picture of that in the sense, here's the average of the models up here, and here's what the surface and upper end, surface adjusted satellite data sets show, that there's a difference here. Now, these end in 1998. It's a little complicated to understand, but here are 30-year trends, 25-year trends that all end in 2008. And you see the models are always above what's actually happened in the real world. Let's add one more year, and we see that the things kind of change quite a bit because, especially over here on the short-term trends, because 10 years, 15 years, just changing 1 year can really have a big impact. So those are kind of flaky there. But the main thing is back here, the longer-term trends do not match up well with the climate models. Now, when we add 2010 after this year is over, which is going to be a pretty hot year because of the El Nino, these will probably flip back up a little bit up into here somewhere. This is a paper we just published last year that shows, in this case, that observations of the upper surface much more than the upper air. That's what observations are showing. That somehow this surface temperature data set that I showed you before that we have questions about, why is it warming faster than the upper air when climate models do not show that? They show something like this, and these are significantly different both for land and ocean. Here is our data set, just updated last Thursday, and shows that this was the big El Nino of 97, 98, warming up the global atmosphere, and here is January right now that's approaching. And I wouldn't be surprised if one of these, if this actually gets up a little bit above one of those things. Now, January 2007, when we had an El Nino, temperature fell right in February all the way down to the bottom almost here. I don't think that's here. This El Nino looks a lot stronger, so I think we'll see some warmer temperatures beyond that. Here's a model result that Sierras, that mountains warm faster than the model simulations, than the valley. This is a greenhouse gas scenario that says if greenhouse gases are warming the air, then the mountains warm up faster than the valleys and the lowlands. That's what model, see this in many, this is just one case. But you know the answer to this one. What we found is that the valley is actually warming for a different reason, and that the mountains are not warming at all. In fact, I just have submitted a paper on snow cover that shows for the last 100 years the snow in the Sierra Nevadas has not gone down any at all. It's still the same amount of snow falling out there. How about here, right here in the southeast, USA, we tried to find a climate model that could have shown what has happened here in the southeast. Now, many of you know that the southeast has seen cooling in the past 115 years or so, 125 years. And there was not one single model that was able to reproduce what has actually happened here in the southeast. Here's a picture, in fact, of temperatures in northern Alabama. By the way, I left in moderate accumulating snow this morning in Huntsville. I was happy just to get out of Huntsville to get south where it's, the sun's out. I couldn't believe it. We have declining temperatures in general throughout the southeast that not one single climate model is able to reproduce. And you can say, well, that's just one area of the globe, but it's our area of the globe. And so we're concerned about whether it's being reproduced or not. This next part is probably the most scientific-y kind of thing I want to show here, is the role of clouds and water vapor. And you have to understand that water vapor and clouds do force the climate. They can be the cause of things that ultimately happen. They're not just responders to things that happen. They can actually do things. Well, here's the deal that I want to show is that clouds and water vapor have a huge, huge impact on whether the Earth warms or not. And carbon dioxide down here and growing. Like I said, we should expect some rise in temperature because of the extra CO2 we're putting back into the atmosphere. But the question up here is, okay, if we add this CO2 and warm up the planet somewhat, does this thing get bigger or smaller? And climate models, it gets bigger. That's how they get these large warming rates out for the next century, is they do things like shrink the cloud cover and make the more sunlight heat up the Earth. But what happens if the real world actually responds in a different way and actually reacts against that heating, so to speak, and has a thermostatic effect? And in real data from satellites, we found that to be the case. What this is a picture of how much energy does it take to make the global climate warm up a degree. How much energy does it take? And what you see here is in the climate models, they're all of them, this is like 1,000 runs of 18 different models. They're down here, which means it doesn't take much energy to make the temperature rise, or that the climate is very sensitive to something like CO2. Okay, the climate's very sensitive. What we found from real satellite observations, this has now been repeated with another satellite, and the answer comes out here, is that it takes a lot of energy to make the temperature go up because of all the things that happen within the climate system that work against a warming effect. What about cold regions and polar bears? Well, you know, all science is numbers, so we got to look at numbers. Here is just one of many of these proxy records for the last 1,500 years. And so these are from tree rings, actually. And what you see here is a scattered picture, but notice that, yes, this last century in which we are in, we have seen warming in the Arctic quite a bit. It started, though, in this record at the coldest spot in the mid-19th century, so we're bouncing back, so to speak, from a very cold spot. And it doesn't reach what had happened even 1,000 years ago in this particular record. We go to Greenland, same sort of thing. I have a lot of confidence in this record. Look at 1,000 years ago. This is now 10,000 years record long. Here's that 1,000 years ago bump that was warmer than it is today. But look at that up there. 4,000 years in Greenland, in which the temperature was much warmer than it is today, and Greenland did not melt. And one of the requirements for rapid sea level rise, which I don't hear a lot of people talking about now, is that Greenland melts rapidly. But Greenland is melting slightly. Sea level is rising and will continue to rise because we're in an interglacial. There is still more land ice to melt. So as I always tell our folks down on the coast, you know, be prepared for the fact that sea level's rising about an inch per decade. And I don't see anything stopping it until the next ice age comes. It's not the inch per decade that's the problem, though. It's the 20 feet with the next Hurricane Ivan. That's your problem. And if you can handle 20 feet in 6 hours from a hurricane, the inch per decade is not your problem. Let's go further south to Kilimanjaro again. We know that the ice up there is really retreating quite a bit, not because of temperature things that's going on, but something else. And what we see here is from 1880. This is the snow cover of Kilimanjaro. It has certainly dropped rapidly since the first measurements were made. In fact, it was half gone when Hemingway wrote the snows of Kilimanjaro. There have been mass gains here there recently, but it's pretty much drying up. But what I'm trying to say there is that though it's often an icon for global warming, you know, you're burning carbon dioxide makes the glaciers of Kilimanjaro go away. It just doesn't square up with what's going on in terms of the climate of this area. And in Antarctica, we find that though the sea ice in the Arctic, the North Pole has really receded, especially about 2007 or so. Just 15 days after that happened, Antarctica reached its highest peak ever. And in fact, the notion that the stratospheric changes are causing a cooling down there at the surface doesn't jive with the fact the last 15 years there's been no change in the temperature of the stratosphere for that part of the world. Now, what about polar bears? Well, in the 60s, there were just a few polar bears, and they were going extinct. There wasn't any question about that when you talk to people about what was going on out there, and that was mainly because of snowmobiles and high-powered rifles, because compared to snowshoes and spears, you know, these two devices are very effective at killing polar bears. And so people noticed that this was not good. We were going to lose polar bears because of the overhunting. And so a couple of Marine Mammal Protection Acts were enacted, And today, there are now about 24,000 polar bears. In fact, Canada allows 800 legal kills per year to keep the population healthy. This is a scientifically determined number so that you can keep the population healthy, sort of like what we do with deer, I guess, around here. You know, they're varmints almost in some places. Okay, so back to science. You know, all science is numbers. Scientifically, you cannot say polar bears are threatened here. Sea level will rise rapidly as Greenland melts. I think I already told you this. You look at the numbers. Here's the sea level rise for the last about 15 years or so. It's pretty steady, going up about an inch or so per decade. But, Bangladesh was supposed to be the place where all this sea level would be a horrific problem as time went on. And the latest satellite results show that Bangladesh has actually added land in the last 32 years. Even though the sea level has risen because of the alluvial deposition and so on, there's actually more land in Bangladesh than there was 32 years ago. And we have this record here that Greenland was much warmer in the past and it did not melt. You've heard this. Dangerous weather is more frequent and more intense in unprecedented ways. This is always the thing you hear when people are trying to scare you about global warming. Well, let's count the events. Tornadoes, are they going up? No, they're not. Hurricanes, are they increasing either in severity or frequency? And no, this is the global and northern hemisphere hurricane record for the last 32 years, and it just goes up and down. If you go back 150 years, it's the same thing, up and down, but it just doesn't, it's not going any particular direction. We'll skip this, is on drought out in the west. This is kind of an interesting part. People make the case that diseases are going to get worse in the future and we can die from malaria or something like that. What is the big thing that helps you deal with diseases? Well, we can see that when we look at this. This was malaria back in 1882. In fact, when they were building the Erie Canal in the early 1800s, malaria was the biggest problem they had to deal with. Well, we've taken care of that because we know how malaria works, and our public health infrastructure has essentially eliminated it from our country. Sweden used to have tremendous numbers of malaria cases back in the 1880s and so on, but again, they are a wealthy country, or became wealthy, and so were able to deal with it. And wealth really is the number one thing. If you want to deal with malaria, make countries wealthy. That will do it immediately. Here's the thing about, you hear they say, oh, we found malaria at a high altitude, therefore these temperatures are causing malaria to rise in altitude. And so here's an altitude over here and latitude for different places, Mexico, Costa Rica, Kenya, and so on. And these are recent papers that said, look how high malaria has been found. Paul Ryder actually went back to the literature, went back and counted events and so on, and he found that when you go back to the literature, that in every one of those places, malaria was much higher in the past. So the fact you see it rising a little bit in some places means it's not even close to where it was before, and I think that indicates that in some of these countries, the public health infrastructure is starting to break down, especially in the tropical poor countries. Let's look at dengue fever. And we see here for a 20-year period, the 3 border states with Mexico, at 62,000 cases. Texas in 1922 had over 500,000 cases, but in this 20-year period, 64. Public health infrastructure, that's the thing that you would concentrate on to deal with these diseases. That's more about dengue. Yellow fever, we had many thousands of deaths in this country. Here's 1878, New Orleans, St. Louis, and so on. 20,000 deaths from yellow fever. No longer a problem. Well, the main point there of that little section was climate in the red. Climate has rarely been the principal determinant in the prevalence of range of all these kinds of diseases. It's how you deal with them with your public health infrastructure. So what I present so far is that the global surface temperature is rising, but in a way inconsistent with model projections of greenhouse gas forcing. And overall, the decline in ice mass, sea level rise about 1 inch per decade, is occurring. No question about that. And severe weather is not becoming more frequent, and diseases are first a function of public health infrastructure. What I think I might be up in testifying before the Senate Committee on EPW this Thursday if they clear the snow out. If I don't, it'd be the second time They've canceled a hearing because of snow in Washington, D.C. on global warming. But please don't demonize energy, because without energy, life is brutal and short. Please understand that. Without energy, life is brutal and short. You don't know how long you were able to live today because we know how to push electrons and use them. It's a tremendous benefit to society. I lived in Africa. I was a physics and chemistry teacher. And this is one of the labs I taught in. Peter Murayuki there is checking the temperature. Most people go to Africa to see a reticulated giraffe or something like that. I went because it was just a terrific experience to educate guys that were just wanted and motivated to learn. But I learned about their energy system. As foresters, you'll know about this. That's the source of energy up there. It's near the hill. And the energy transmission system is the backs of women. And I would see them every morning at dawn get up and walk. The UN estimates an average of 3.1 miles to the edge of the forest, chop down about 50 pounds of wood, put it on their back, and haul it home. And they were beasts of burden in that sense. It's a very poor energy transmission system, but even worse is the energy use. And I've been in many of these homes, these huts, where the smoke, I hope you can see the smoke right there in the hut. The UN estimates between 3 and 5 million children die each year because of this, respiratory illnesses and so on, from this energy system. And if there's one thing I learned in Africa, I learned many things, but one thing was that African parents love their children. And when their child dies, they grieve inconsolably. I have 4 grandkids now, little grandkids. I just love them to death. I will do anything to make sure they survive any harm that might come their way. African parents are the same way. They don't want to see their children die. I don't tell you that to tug at your heartstrings. I'll just tell you this. Energy demand will grow. There is just no question that energy needs and demand will grow through time. That is going to happen. So here's a dilemma. Suppose you want to do something about global warming. Maybe you've been convinced by things like polar bears going away or sea ice going away that this is a terrible thing to happen. I want to do something about global warming. So here's the dilemma. How are you going to meet significant growth in energy demand and reduce CO2 emissions so you can thus manage the climate, which I don't think you can do, but let's just say that that's an hypothesis you want to follow. You want to manage the climate. Well, what did California do? Which now, by the way, I should put the United States because they're principally following this lead. They forced a limit on emissions of light-duty vehicles, and they passed California AB 1493, which seeks to reduce tailpipe emissions by 26% by 2016. And, that's all slid to the future now, but it's still going to happen probably. Now, that means to sell cars in California, the fleet average, and this is light-duty vehicles, so it includes SUVs and trucks, okay? The fleet average has to be 43 miles per gallon. So you sell the popular stuff, the 25 mile per gallon stuff, you got to sell something at the 55, 60. There aren't any things that people buy at that rate. So to get the average, how are you going to do it? Well, there was 11 northeastern states adopted this thing, and there was a trial in Burlington, Vermont in 2007 because the automobile manufacturer sued and said, this is impossible. We can't build a set of cars that people will buy whose average is 43 miles per gallon. Well, they did throw in a little section on climate, and so I was asked by the Alliance for Automobile Manufacturers to testify on their behalf about climate issues. And then on the other side was James Hansen, actually Gavin's boss, talked about his view of climate there as well. Well, here was the guts of my testimony, and it says, okay, let's assume that the climate is going to warm according to the best guess of the IPCC. I don't think it's going to happen. It's not happening at this rate. So, but let's just assume that's what it's going to be. What would happen if the entire country observed and adhered to this law? Not only just accepted it, but actually adhered to it? Well, this is what happened. I'm going to overlay the result on the global temperature from this bill if the entire country used it, okay? I'm going to overlay it, and this is the result. It's actually less than 1/100th of a degree. In other words, it is so tiny we cannot measure it, even with the best satellites we get. We cannot measure that kind of change. The environment wouldn't know it at all. In fact, if the entire world adopted this measure, the entire world is only 3/100 of a degree. Again, too small to even measure and deal with. But the judge ruled for the Attorney General who were trying to promote this law in the states. Now, the truth is, the main body of the text was about legal issues, and the judge really came out to say the states have the right to make this rule. So it really hinged on that kind of thing. Now, maybe many of us in the South say, well, that sounds pretty good, states' rights. I like that result, you know. And that's basically what he said. States do have the right in this federal versus state issue to do this. But he did say, plaintiff's expert Dr. Christie estimated that implementing the regulations across the entire United States would reduce global temperature by about 1/100 of a degree. 2100 Hansen, the other side, did not contradict that testimony. I mean, he couldn't, because the numbers were just bulletproof, that this would have no effect. So if you read the decision, the judge says, you have the right to do this, and it won't have any effect at all on the climate. Okay? That's the result of that decision. Well, it's been appealed, and all kinds of other decisions or court cases are hanging up out there right now, so no telling where this will go. Probably it'll end up in Congress. What could, and then that's where you laugh, yeah. What could make a dent in forecasted global temperatures? I also did the work on that because I was curious myself as a scientist. By the way, I didn't take a single dime for that whole process. I did all the work and background, but I didn't take any money at all because it was an interesting scientific question for me because I don't take money from industry like that. What would be the impact of building 1,000 nuclear power plants and putting them online by 2020? Okay, these are 1.4 gigawatts each. The one up there in Browns Ferry is about 1.1. This isn't going to happen. John McCain campaigned on the issue of 45 nuclear power plants to reduce emissions, but I said, let's build 1,000. It's not going to happen, but what would the impact of 1,000 1.4 gigawatt plants be? Let's do that experiment again, and this is it. We can now start to measure it, at least with our satellites, but the impact would be so small, nothing else in the world would really know except our satellites, basically. So the impact is extremely small, even for that amount, which tells you there must be a lot of CO2 going into the air right now if 1,000 nuclear power plants just make a little dent like that. Well, that's the truth. There is a lot of CO2 going out in the air because of tremendous benefits it gives to us. We don't do it out of malice. We do it because of the benefits it provides us. And a longer life, that's a pretty nice benefit when you think about it. So the main points, without energy, life is brutal and short. Proposed do something about global warming initiatives will not detectively alter whatever the climate is going to do. And making energy more expensive is a regressive tax and stops economic development. And we know that very well here in the South, where we have the benefit of many industries that have come here because of our low cost of energy. And they don't have anywhere else to go in our country when they have to leave here. If our energy prices go, they will be in Mexico, they will be in China. They will not be providing those jobs and benefits that we have here. And I know in Alabama, as well as you in your other states here in the Southeast, know that when someone has a job, they have things like health care. They have this notion that I can send my kids to college and so on, have real benefits, societal benefits, because of this kind of manufacturing and so on. And if we lose that, our country will be in much more terrible straits economically. If something isn't economically sustainable, it's not sustainable. Okay? You hear a lot of talk about sustainability with this, that, and the other. If it's not economically sustainable, it's not sustainable. So that should be the first check on those kind of things. This is nothing important here. My high school physics teacher was pretty smart. He said, we should always begin our scientific assessments with this statement. At our present level of ignorance, we think we know. And I think for climate, nothing else could be more obvious and true than that statement. It is such a complex thing. We don't know most of what goes on in the climate system or how to predict it or how things respond to any kind of forcing that comes along. It's very difficult, and I think you've seen a lot of overstated confidence in the past in these official reports about what the climate system is doing. Because if we did actually understand it, we would be able to predict it, and that hasn't been the case that I've been able to see and detect and study in these times. Now, my last transparency is two cavemen are talking. Something's just not right. Our air is clean. Our water is pure. We all get plenty of exercise. Everything we eat is organic and free range, and yet nobody lives past 30. And I want to say that in a very somber note, because as someone like me who's lived in Africa, I've seen what happens when people don't have energy. They die. Children die when that occurs. Now, I'm a grandparent, I told you that. I can tell by looking at this audience, many of you are grandparents. And there's nothing better when that little kid comes up and grabs you around the knees and says, "I love you, Grandpa." That's an experience of life you and I can have these days. 100 years ago, we could not. The average American lived to be only 47 years old. But energy technology and all the benefits that came about have brought us to this level of life experience that could not have happened otherwise. So my point there is you be very, very careful when you start talking about, I think we might do this for energy so that we'll do something maybe about the climate, when in fact it has real impacts on people, especially the poorest among us. When we start making energy more expensive, that will have negative impacts on the human existence and on human life. That's something we have to be very careful and cautious about as we go forward. So with that, I'll finish. Thank you.